In this next part of the presentation, I'll be talking about how our body will recover from different activities. Recovery is the restoration of the body systems to resting levels such as breathing rate or heart rate. At the same time, we will resynthesize energy stores such as ATP and the PC stores. In addition to that, we will repair the damage that is caused during training or competition, as during training you will cause micro tears in the muscles, which will eventually heal over and strengthen them again. Epoch is when the VO2 is above the resting levels in recovery. This is to help the body return to resting levels. Oxygen deficiency can differ depending on the duration of the activity. For example, as you can see on the right hand side, we have a much higher intensity but a very low duration, compared to on the left side where it's more of a moderate duration and we'd presume moderate intensity. As you can see, there is a much bigger oxygen deficit during the higher intensity than the lower intensity. This means that more oxygen is required after the exercise to help the body recover than during the exercise where it's likely to be aerobic. As it is aerobic, that means the oxygen deficit will be less because during activity they'll be consuming oxygen and that'll be used to help reduce the oxygen deficit. There are two main parts to recovery. The first component is the fast recovery. As you can see on this graph, it's the part that is labelled A. It's the part that happens first. This is known as the lactic recovery. This is where the body replenishes the ATP and PC stores. Also replenishes myoglobin and hemoglobin with oxygen, so oxygen is able to be transported around the body in the bloodstream to the muscles, which will then reduce the oxygen deficit. This can take a couple of minutes. However, 50% of the PC stores are replenished within the first 30 seconds. As you can see from this graph, which is labelled 120 seconds, around 30 seconds there is 50% of the ATP restored. This part of the recovery will use 1 to 4 litres of oxygen. As it only takes 30 seconds, this could be small rests during games. As you can see in this graph on the top right, there is time to recover, and in this recovery time, all the ATP and PC stores will be replenished. Therefore, it can be used again and then replenished again, as it's such a quick recovery method. The second part of recovery is the slow recovery, which is also known as the lactic acid slow recovery. As you can see on the graph at the bottom, this is the part that is labelled D, and it will take a lot longer to occur. During this process, it helps remove lactic acid from our muscles and our body. At the same time, we will restore glycogen, and CO2 and H2O will be removed. This can take from anywhere from minutes up to hours, and it will use 8 litres of oxygen. As you can see from this graph, after an hour, the oxygen debt is still not 100% repaid, and therefore it can take a lot longer to occur. Lactic acid is removed by the body from a process. This is because when lactic acid combines with oxygen, it will form many different components, such as pyruvic acid, and then 65% will be CO2 and H2O, 25% glycogen, 5% glucose, and 10% protein. This is how the lactic acid will be broken down in our body, and it all happens during this slow recovery process. Metabolic needs. After exercise, extra VO2 will be consumed, and it will be used by the organs and muscles, such as respiratory muscles, as they attempt to return to rest. Heart rate will remain slightly elevated after exercise, as the muscles need oxygen to help maintain a high breathing rate and a higher ventilation. Breathing rate will also remain high, as the blood needs more oxygen to supply the heart with muscles, so the higher heart rate can be maintained during recovery. This is all important, as it will help the body return to normal and remove the oxygen deficit. At the same time of removing the oxygen deficit, it will also remove more CO2 from the body, and at the same time allow a gradual decrease of the core body temperature. During this process, the heart will also need more oxygen, as it tries to maintain a higher heart rate. This process will need more oxygen, hence why the breathing rate will increase. remain higher as it needs to intake more oxygen. As you can see from this graph, the resting levels of breathing rate is around 70. It will then increase during exercise, and as recovery starts, it will still remain higher, and then eventually after about 10 minutes or 10-15 minutes it will drop down, and then after 20 it will be back to normal. At the same time, the heart rate will at rest is around 75. During exercise it will then increase rapidly, and then it will plateau. After that, it will still remain slightly elevated as it needs to pump oxygenated blood to the working muscles, and at the same time take the carbon dioxide and the lactate out of the muscles. There are some ways to help recovery. One is through cryotherapy. This is, for example, an ice massage or an ice pack. This will cause sudden vasoconstriction of arteries in the muscles. However, once the ice pack or ice massage is removed, it will then cause sudden vasodilation, which will increase the blood flow and help with the removal of many different components such as lactate or carbon dioxide. It will also help decrease muscle pain or muscle spasms, and it will help the muscle tissue metabolize. DOMS is the delay of muscle soreness. This is because the muscles can be sore a couple of days after due to an injury to muscles or the connective tissue. Excessive contractions can cause large structural damage to muscles, and muscle protein breakdown can cause muscle inflammation. Another recovery method is active recovery. This is normally like a light jog or something very low intensity that helps. This will cause the skeletal muscle pump and will help remove lactate and CO2 out of the muscles. This is because when the muscles are contracting whilst moving, they're constantly squeezing the blood up and out of the muscles, and then it will be replenished with new oxygenated blood. This will help maintain venous return, and it will also reduce oxygen debt in the muscles, as when the oxygenated blood will flow to the muscles, oxygen will then diffuse into the muscle. As you can see from this graph, the group who did no exercise after their event, they had a much higher blood lactate concentration, and it remained high for longer. However, if they had light exercise, then the blood lactate concentration decreased quite a lot quicker and almost returned to resting levels after 30 minutes. Active recovery will also prevent venous pooling, as blood will no longer get stuck in the valve pockets in the veins. Another method is recovery intervals during training. These are built-in recovery times during training. For example, you can do a high-intensity burst of something and then recover during the time allowed. This will be useful in either basketball training or football matches. In basketball training, you could allow them to do quick bursts of intensity and then give them a couple of minutes break, which will allow the ATP or PC system to replenish. Or in a game of football, for example, there'll be natural built-in rest times, for example, a half time. This will allow, again, all the energy stores to be replenished with the ATP and PC that are needed. This is a different recovery method compared to the likes of the active recovery or the cryotherapy, as recovery interval training will happen during your training session, whereas the others will occur after the session. Just going back to EPOC, during a high intensity event such as weightlifting or powerlifting or 100 meters, this will be different to the time needed to recover compared to a lighter intensity such as, say, a half marathon or something. This is because during the higher intensity they will use the ATP PC system or the glycolytic system, compared to the duration activities where they'll most likely use their aerobic energy system. This means that because of the use of the anaerobic glycolysis system, lactic acid will be produced, and therefore it will cause fatigue. And because of that lactic acid, it will need to be broken down during recovery. Whereas with the aerobic system, they don't need to break down any other chemicals or something. They just need to get rid of the H2O and the CO2 in the body.